intersection. We've been doing law of sines and law of cosines, and now we're going to find area of triangles. So if I have a side angle side triangle, and again, I've given you an abundance of information. These are all the exact same formula. It just depends on if you're given an angle of C, an angle of A, or an angle of B. And then the remaining sides that you're going to take a product of are the flanking sides that create the angle. So the area K of a triangle equals 1/2 of the product of the sides times the sine of their included angle. Well, that's all fine, great, and wonderful. We may have to get to a point where we have an SAS triangle, but once we do have it, then we can find the area. And again, in geometry, the area of a triangle is half the base times the height, but we're in pre-cal, so it's not going to be that straightforward. We have, if we've got a side, 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 which means we have no known angles, we're going to apply Huron's formula. And that's going to be K equals the square root of S times S minus A, S minus B, S minus C, where S is half of the sum of all three sides. So basically, you're going to find half the sum of the sides and put it here. And then take that answer minus a side, that answer minus another side, and that answer minus a third side. Take the square root and you're done. So those are the formulas that we're going to use. So let's just start off with our friend the triangle. Okay, so if I've got a 45-degree angle and I've got a 2 here and a 5 here, what that means is I have side, angle, side, which means I can use the traditional method of finding, traditional and pre-cal, of finding the area of this triangle. So I'm told that K equals half of the, half of the product of the sides times the sine of the included angle. Half of the product of the sides times the sine of the included angle. So when I do this, I get half of 10, which is 5, times the sine of 45. So I'll have 5 times the sine of 45 gives me 3.54. So the area of that triangle is 3.54 units squared. Anytime you're finding area, it boils down to length times width. You may have to finagle it some, but length times width means you've got a length and a width, which is 2 dimensions. Okay, so area is always 2 dimensions. Anything linear, like length or just width or just height, those are not those are linear, so your degree is 1. So it would be in units of single units. And then cubes would be length times width, which is planar, and then times height, which takes it into the 3rd dimension, which is why it's cubed. Anyway, fun fact. Okay, so let's try it again. I have another triangle, and I've got a 70, and I got a 3, and I got a 5. So again, I've got a side, angle, side, so I can use what I know about finding the area, and I'm going to take half. Sorry, I had to yawn. All right, half of the product of the sides times the sine of the included angle. So I've got half of 15. So half times 3 times 5 times the sine of 70 degrees gives me 7.05. So this has an area of 7.05 units squared. So let's try another one. We have, oh my goodness, we have side, side, side. So I'm given this triangle where this is 12 and this is 9 and this is 5. So the first thing I need to recognize is I'm going to be using Huron's formula. So I find S by taking half of the sum of the sides. So 12 plus 9 is 21, plus 5 is 26, and half of 26 is 13. So I know that S is 13, so I'm going to find this by using S times, and then 13 minus 13 minus 13 minus the sides. So 13 minus 9, 13 minus 12, 13 minus 5. So you can either let your calculator do the work, or we can do a little bit of work up front. 13 minus 9 is 4, 13 minus 12 is 1, and 13 minus 5 is 8. So the square root of 13 times 4 times 1 times 8 is going to be 20.396, which is going to be 20.40. 20.40. So this is 20.4 units squared. Okay, so let's try a couple more. Excuse my stupid dogs in the background. All right, so I am given a little a of 3, a little b of 6, and a big C of 35. So instead of drawing this triangle or making our little chart like what we've been doing, do any of these correspond with each other? In other words, I've got a big C of 35 degrees. Do I have a little c? No. Then you have angle, side, angle. Okay, so as long as these three don't correspond with one another, you have angle, side, angle. So I can find the area of this triangle by doing half of the product of the sides times the sine of their included angle. So that gives me half of 18 is 9 times the sine of 35. So I get 5.16. So this is 5.16 units squared. Okay, let's do another one. So I've got B is 2, and C is 4, and big A is 80. Okay, so do I need to do any work? Do any of these correspond? No, I'm so sorry. I'm tired, and now I can't stop yawning. So big A does not have a little a. Little b doesn't have a big B. Little c doesn't have a big C. So none of these correspond, which means I must have angle, side, angle. So I find that by taking half of the product of the sides times the sine of the included angle. So finding that, I get half of 8 is 4 times the sine of 80 gives me 3.94. So this is 3.94 units squared. Okay, so let's try another side, side, side. So I've got A is 15, B is 17, and C is 8. So none of these are angle measures. These are all sides. And I'm supposed to find the area of this triangle. So I'm going to be using Huron's formula. So the first thing I need to know is what S is. S is half the sum of all three sides. So I get 8 plus 15 plus 17. So 15 and 17 is 32 plus 8 is 40. Half of 40 is 20. Okay, so I know what S is. So now I can come up here and find out what K is. So I need to put S times 20 minus one side, 20 minus another side, and 20 minus the third side. So one of those is an 8, one is a 15, and one is a 17 that you can't see. There you go. So again, either let your calculator do all that work, or we can simplify our input a little bit and do 20 times 12 times 5 times 3. So 20 minus 8 is 12, 20 minus 15, 20 minus 17. So the square root of 20 times 12 times 5 times 3 gives me 60. You can't see. That gives me 60. And that makes me happy because it is not anything rounded. So it ended up being a very, very pretty area. All right, so let's try another one. We have color change. We have A and B and C are all 10. So again, I'm not given any angle measures, however you know the angle measures, because this is an equilateral triangle, which means it's also equiangular. So this is 60, 60, 60. Okay, but we don't care because we're going to use Huron's formula. So I need to know what S is first. So half of the sum of the 3 sides gives me 15. So then K equals the square root of 15, and then 15 minus 10 times 15 minus 10 times 15 minus 10. So 10 minus the first, sorry, S minus the first side, S minus the second side, S minus the third side. And so I end up with K equals 15 times 5 times 5 times 5, which is going to give me the square root of 15 times 5 times 5, which you still cannot see. And I get 43.30. So, 43, what? 0.30. Oh no, 43.30 units squared, whatever your units happen to be. All right, so let's do a couple more. We can do 3 more in here. So I've got 11, 13, and 20. So A is 11, B is 13, and C is 20. So again, I'm going to use Huron's formula. So 11 plus 13 plus 20 is going to give me 11 and 13 is 24, 44, which is going to be 22. Okay, so add those together, divide by 2, you get 22. And so my formula is K equals 22 times 22 minus each side. So this is going to be, it doesn't matter where you put the sides as long as you don't repeat them. So just for ease of entering, 22 minus 11 is 11. 22 minus 13, I don't know, is 9. And 22 minus 20 is going to be 12. You can tell it's getting late because my brain is fritzing. All right, 22 minus 13 is 9. 22 minus 20 is 12. There we go. So the square root, that's not the square, yes it is the square root. The square root of 22 times 11 times 9 times 12 gives me 161.67. So 161.67 units squared. All right, so the next two, so this is going to go just a couple minutes long, but it's a nice stopping point, is going to be, they're going to give us formulas. You are given these within the problem, okay? So I am told that I can find the area if K equals A squared times the sine of B times the sine of C all over 2 times the sine of A. So this is a new formula, but they gave it to us. So I'm also told that A is 10, B is 20 degrees, and little a is 2. So I notice right off, I need the sine of C, and I don't have a C. But wait, I have 2 angle measures out of 3. So I can rapidly figure out that big C must be 150, because 180 minus 30 will give you 150. So just plopping this thing in here, I have K equals A squared, so 2 squared is 4, times the sine of B, which is 20, times the sine of C, which is the sine of 150, all over 2 times the sine of A. So that's 2 times the sine of 10. Now, be careful. You can go ahead and reduce this 4 and this 2 right here and make it a 2. But if you don't, you better make sure that this entire denominator is in parentheses when you put it in your calculator. Otherwise, your calculator will say 4 times the sine of 20 times the sine of 150 divided by 2 times the sine of 110. So it's not going to include that sine of 110 in your denominator. So to avoid that, I'm just going to rewrite that as a 2. And now I don't have to worry about it. So I have 2 times the sine, where'd it go? The sine of 20 times the sine of 150 divided by the sine of 10. And now I don't have to worry about that, putting my denominator in parentheses. And I get 1.97 square units. So 1.97 units squared. And then let's just do it one more time real quick. And then we'll do, in a second video, we'll do 3 or 4 problems. So it's going to be the same formula. We're just kind of sort of changing it up a little bit. So I've got k equals b squared times the sine of a times the sine of c all over 2 times the sine of b. So you'll notice that your b here is going to be divided by its sine of its angle. So what am I given? Atlantic Ocean. B is 70. Big B is 70. Big C is 40. And little b is 4. Which means I need to know what big A is. So I know that this is 110. So 180 minus 110 is going to be 70. So A is 70 degrees. So my formula is k equals b squared, which is 16, times the sine of A, which is 70, times the sine of C, which is 40, all over 2, times the sine of B, which is 70. Oops, sorry. Sine of B is 70. And I'm always looking to be a lazy math person. Well, 16 over 2 reduces to 8. And then sine of 70 divided by itself is 1. And then I get the sine of 40. And I'm only doing that because it makes my life easier when I'm entering it in the calculator. So 8 times the sine of 40 gives me 5.14 square units. 5.14 units squared. Okay, so that is the intro to 9.4, and then we'll do a handful of word problems, and you'll be done with 9.4.